Dear student, welcome to the lecture series of nanotechnology and material science. Today we will discuss about one of the famous technique known as plasma enhanced chemical vapor deposition. Plasma enhanced chemical vapor deposition technique is a core technique of semiconducting and dielectric industry. Plasma-enhanced chemical vapor deposition process is a hybrid low-temperature CVD process used to deposit a thin film due to a chemical reaction of a precursor or a reactant present in the form of a plasma on the surface of substrate. So in conventional chemical vapor deposition process, a precursor gas is injected inside a reaction chamber, and the reaction chamber is basically heated up to 1200 degrees centigrade, and after that a gaseous precursor is basically chemically reacted on the surface of substrate. However, in case of plasma enhanced chemical vapor deposition process, we don't need high temperature. We just basically convert a gaseous precursor into a plasma, and then that activated plasma is chemically reacted on the surface of substrate, and at the end we get deposit a thin film. In plasma enhanced chemical and vapor deposition process, the deposition is achieved by introducing a reactant gases between the parallel electrodes. One electrode is grounded, and it is a grounded electrode, whereas the second electrode, which is a top electrode in plasma enhanced chemical vapor deposition system, is known as RF energized electrode. This RF energized electrode is operated at higher frequency and high voltage. The RF energized electrode basically operate at radio frequency, which is 13.56 megahertz. So the capacitive coupling between the electrode, bottom and top electrode, excites the reactant gas into a glow discharge or a plasma, which induces a chemical reaction and result into a reaction product being deposited on a surface of a substrate as a thin film. So in a simple word, dear student, in a chemical vapor deposition process, there are two types of electrode used. One electrode is basically RF activated top electrode, which operate at very high potential, and the frequency of RF energized electrode is around 13.56 megahertz, whereas the bottom electrode is basically a grounded electrode. So due to a capacitive coupling between the top and bottom electron will result into an introduction of plasma, or into a creation of a plasma, or into a generation of a plasma of the reactant gas. And due to a generation, or due to a conversion of reactant gas into a plasma, the reactant gas becomes chemically active, and it reacts on the surface of the substrate, and as a result we get a thin film by plasma enhanced chemical vapor deposition process. Dear student, plasma enhanced chemical vapor deposition process is a core technique of semiconducting and micro fabrication and dielectric industry. Dielectric insulating material like silicon, silicon dioxide, silicon oxynitride, silicon carbide, and amorphous silicon based thin films are most commonly prepared by plasma enhanced chemical vapor deposition process. And that's the reason that PECVD is a core technique used in microelectronic and semiconducting industry. In contrast to conventional chemical vapor deposition process, plasma enhanced chemical vapor deposition process use a plasma as a source chemical reaction activation energy. rather than high temperature which is used in chemical vapor deposition process. This means you can do a deposition at much lower temperature as plasma give you much activation energy just like thermal energy. This means that we can deposit a material on the substrate which cannot tolerate high temperature. In a simple word, chemical vapor deposition process is done at much higher temperature, whereas in plasma enhanced chemical vapor deposition process, a reactant gas is converted into a plasma at very low temperature, and the activation of the reactant gas as a plasma basically has a same energy just like the thermal energy which is created due to a chemical vapor deposition process. So the plasma basically of the reactant gas become chemically active, and as a result the chemical active plasma will react on the surface of the substrate and it will convert it into a thin film. So this means that you can deposit a thin film at much lower temperature by using plasma enhanced chemical vapor deposition process. So this means the plasma enhanced chemical vapor deposition process is a technique which can even deposit a thin film on a substrate, on those substrates who cannot tolerate high temperature. So you can basically deposit a thin film at much lower temperature on the substrate which don't tolerate the temperature. Now dear student, let us discuss about the basic parts of plasma enhanced chemical vapor deposition system. Let us represent the basic parts of plasma enhanced chemical vapor deposition system by a schematic diagram, and let us discuss about how we can basically deposit a thin film by using plasma enhanced chemical vapor deposition system. Dear students, PECVD consists of a reaction chamber. Reaction chamber is a chamber in which a chemical reaction takes place and we get a thin film. PECVD consists of a substrate holder. Substrate holder in PED system is known as platen. So the platen is basically used to hold a substrate in a PECVD system, or a substrate is basically placed on a platen of the PECVD system. PED system consists of a source or precursor gas containers and a source gas lines. The precursor gases or source gases used in PED systems are usually silicon dioxide or silicon nitride. Dear student, please note that there may be a wide range of precursor gases used in PECVD systems. However, in order to understand what could be a possible chemical reaction and what type of thin film you will achieve at the end of the day, you can adjust the precursor gases in a PECVD system. So there is a lot of chemistry involved in order to understand that what kind of gases we can use in PECVD system. PECVD system basically have a high voltage radio frequency top electrode. High voltage radio frequency is responsible to convert a precursor gas into a plasma. So it is a very important constituent of plasma enhanced chemical vapor deposition system. PECVD system consists of a grounded bottom electrode. Okay, the bottom electrode is basically, it is a flatten of the PECVD system, and on that electrode usually a substrate material is placed and it is grounded. So high capacitance is basically created between the grounded and RF top electrode, and due to a high capacitance this will result into a higher potential difference, and at the end of the day we basically convert a reactant gas which is present between the top and bottom electrode into a plasma. PECVD system is connected with RF power supply. So there are some systems which are connected with direct current and alternating current power supply. However, most commonly radio frequency with high voltage is used in plasma enhanced chemical vapor deposition system. Though direct current is also used to produce a glow discharge, but there are a lot of issues with DC and AC power supply, and that's the reason radio frequency high voltage source is used to generate a plasma in PECVD systems. The student PECVD system is connected with a vacuum pump. You basically need a clean environment to deposit a thin film inside a reaction chamber. And in order to achieve a clean environment without any kind of a collision of gaseous molecules inside a reaction chamber before they reach the substrate, you need a clean environment, and the environment of the reaction chamber is cleaned by using a vacuum pump which basically evacuate a reaction chamber up to 1 millitorr to few torrs. And the pump which is used in PECVD system is usually a mechanical pump. PECVD consists of a gas inlet and outlet or exhaust setup. So basically the gas inlet mean an inlet through which a precursor gas is incorporated inside the reaction chamber of the PECVD system. Whereas the gas outlet is basically an exhaust line through which the byproduct is removed from the PECVD system. So now let's, dear student, describe the deposition of a thin film by plasma enhanced chemical vapor deposition process using schematic diagram. This plasma enhanced chemical vapor deposition system consists of a reaction chamber. Consider this as a schematic representation of a reaction chamber. The reaction chamber has a substrate holder, and this substrate holder is usually known as platen in PECVD system. The platen is basically, it is connected with act as a bottom electrode. So this platen is grounded in PECVD system. So dear student, you basically have to deposit a thin film on this platen, and the substrate is placed on a platen, and on the substrate you have to deposit a thin film. CVD system is connected with a vacuum pump. Usually this vacuum pump used in PECVD system is a mechanical pump which usually evacuate a PECVD system up to a few millitorrs. PECVD consists of a top electrode. Top electrode is very important part of the PECVD system. The top electrode is connected or it's operate at very high potential. The top electrode of the PECVD system is connected with a high potential radio frequency power supply which operate at 13.56 megahertz frequency and very high voltage. Dear student, please note that the PECVD system, as I have discussed, that it has a platen. In order, if you want to deposit a very comprehensive thin film with a better diffused with a better diffusion with a substrate, you need to heat a substrate. In order to heat a substrate, we have a bottom heaters. They are basically present below the flatten. So basically in PECVD system, a flatten is heated around 2 to 400 degrees centigrade by the heater, and when the flatten is heated, a substrate usually is placed on the flatten or bottom electrode. The substrate will be heated, so this means that you will have a slightly hot substrate, and when the film is deposited on a substrate, it will betterly diffused on the surface of the substrate, and at the end of the day you will get a better deposited thin film. So in order to have a better deposition of the thin film, we use our PECVD system have a heater, and these heaters are connected with bottom or flatten or substrate or flatten or substrate holder of the PECVD system. On the top of the flatten or on the top of the substrate holder, we basically have a substrate. So now just let us discuss that how we can do a deposition of a thin film by using this PECVD system. In order to deposit a PECVD deposited thin film, we need to evacuate the reaction chamber of the PECVD system. Before doing evacuation, we basically incorporate a substrate on the flattened or on the substrate holder of PECVD system like this. Okay, so basically we have introduced a substrate on the flatten or on the surface of the substrate holder. So now you have basically introduced a substrate holder. Then the PECVD system reaction chamber is evacuated by a mechanical pump up to a 1 torr or up to a few millitorrs. So the environment of the PECVD reaction chamber is basically cleaned. After cleaning the environment of the PECVD reaction chamber, a high potential is applied with a radio frequency of around 13.56 megahertz inside the reaction chamber of the PECVD system. So your chamber is ready for deposition of thin films. So now you have to introduce a precursor gas inside the reaction chamber. So precursor gas will be introduced from a precursor gas line which is basically present outside of the PECVD reaction chamber. So when the precursor gas enter between the top and bottom electrode of PECVD system, since the potential difference between the top and bottom electrode is very high. So due to a very high potential difference, this precursor gas will be converted into a fourth form of net matter, and which is known as plasma. So basically you will get plasma between the top and bottom electrode of PECVD system. This plasma which you achieve between the top and bottom electrode is chemically active, and this plasma will be deposited on a surface of this substrate, and as a result you will get a thin film like this. So this active plasma which is created due to a higher potential between the top and bottom electrode will be deposited on the surface of this substrate, and at the end of the day you will get thin film. Keep in mind that when a chemical reaction is done by a chemically active plasma on a surface of the substrate, you basically get a byproduct, and that byproduct is basically removed by exhaust system, or basically you may open and clean the reaction chamber, and you may remove the byproduct after the cleaning, after the de-evacuating the reaction chamber of PECVD system. So now if I explain the thin film deposition in PECVD system, I will say that PECVD system basically consists of a reaction chamber. In order to deposit a thin film in PECVD system, reaction chamber is evacuated. So you will have a vacuum around a pressure around 1 millitorr to few torrs. So after evacuating the PECVD system, the PECVD system consists of a top and bottom electrodes. The top electrode operate at radio frequency and high voltage. So when the precursor gas is incorporated from outside inside the reaction chamber of PECVD system, the precursor gas, due to a high potential difference of top and bottom electron, will be converted into a plasma. Since the substrate is placed on a flatten of a PECVD system, the chemically active plasma will basically will interact with the surface of the substrate, and the chemical interaction of the chemically activated plasma on the surface of substrate will result into a deposition of a thin film. So the thin film deposit at in a PECVD reaction chamber will also give a byproduct, and that byproduct will be removed through an exhaust setup. So dear student, if you want to prepare a thin film with a PECVD system, initially you need to evacuate a PECVD reaction chamber, and then you need to apply high potential between the top and the bottom electrode, and after that a gas precursor will be incorporated between the top and bottom electrode of the PECVD system. So the precursor gas, due to high potential, will be converted into a plasma, and that plasma become chemically active, and it will be deposited on the surface of the substrate. So in this way you will get a thin film on the surface of the substrate. After completion of the deposition of plasma, you will de-evacuate the reaction chamber of PECVD system, and after that you can remove your sample from the PECVD system.